Hi guys, I Aziz welcome you to CoedMaster. In this video, I am going to talk about internal working of ArrayList. If you are willing to learn how ArrayList internally works, then make sure to watch this video till the end. So let's get started. Alright, so guys, to understand how ArrayList works internally, we first have to understand what is array and how it works internally. So what does it mean by array? So array is a basic data structure used to store multiple values, right? And how does it work? This is the syntax to create an array. And what this syntax does? It is going to pre-allocate space for 5 elements and the type of that elements are integer, okay? So this is how space for 5 elements is pre-allocated in the memory and we enter all the elements one by one. So currently this array has 5 elements. That is why the size and capacity of this array is 5. Now what happens when we want to add new element to this array? Now when we try to add new element to this array, we get error. What a bummer it is. So these are the few major issues we face while working with arrays. The number one reason is it is fixed size. This means the array cannot grow or shrink based on the number of elements. And the second major problem we face while using array is it can only store homogeneous elements. In case of this array, it can only store integer values. It cannot store boolean or float or any other type of values. So guys, to fix all of these issues, ArrayList collection comes into picture to rescue us. So now let's understand what is ArrayList. So ArrayList is a collection class and it is an implementation of dynamic size array. Now this begs the question that what does it mean by dynamic size array? So in layman's term, the array that grows and shrinks in size automatically, we call it dynamic size array. So does that mean that it lost the property of storing elements in contiguous memory location? Absolutely no. The ArrayList still holds this property of storing all the elements in contiguous memory location. But along with this property, so now it also has new property that is the growable nature. This means the dynamic size array or ArrayList can grow as per the number of elements or shrink based on the number of elements. So far so clear. Now let's see how ArrayList actually works. So this is the syntax to create ArrayList of size 5. So what happens here, the space for 5 elements will be allocated in the memory. And this memory is a contiguous memory, right? So we add all the elements one by one to all the spaces. Now what happens when we add new element to this array? Let's say I want to add new element 6 to this array. But as you can see that the ArrayList is full and the capacity of ArrayList is already 5 and we have already 5 elements in the ArrayList. So in this case, ArrayList behaves very smartly and what it does? It simply creates new array and the size of that array is much larger than the existing array. And then he smartly copies all the values from previous array to new array and then add new element to it. Okay, so as you can see that this is the new array where all the elements are present from 1 to 5 and then the new element is present after 5 at position 6. Okay, so this is how dynamic array resizes itself when we add new element to it in case it is full. Okay, and after creating new array, it simply releases old space. And vice versa, if we remove elements one by one, let's say if we remove 6, 5, 4, it's going to shrink the size of the array internally. Okay, that is why we call it growable ArrayList. It can grow in size or it can shrink in size. Okay, now here you may ask that by what factor the array grows internally. So to answer your question, it entirely depends upon the implementation of the programming language and it also depends upon the two important factor, that is capacity and load factor. So for example, in Java, the load factor is 0.7 and the capacity of array is 10. Okay, so in every insert operation, it's going to calculate the threshold. And how threshold is calculated? It's simply 10 into 0.7, that is equal to 7. So this means till 7th element, it's not going to resize itself. But as soon as you try to add new element at 8th position, it's going to resize itself internally. So guys, I hope now you understood how ArrayList actually works internally and by what factor ArrayList grows and shrink in size. Okay, so now the question over here is, So now the question over here is, if the last element is creating new array of size greater than the existing array or the previous array, then obviously it's going to take more time to add elements in the last of the array, but this is not the case. Let me show you why. So let's say the initial size of array is 5 and we add all the 5 elements to this array. As soon as we add new element 6, it's going to resize itself and create new array that is greater than the previous array. Okay, so we can say that the time complexity of this operation, meaning the last element, meaning the operation of the last insert, we can say that till 5 elements it is taking big of one constant time to add new elements, right? Because we have already free space available for all the elements till 5. For example, first we add 1, then we add 2, then we add 3, then we add 4 and then 5. So it's going to take big of one constant time to add all the elements. But as soon as we try to add new element, it's simply going to take theta n time to add the new element. And why theta n? Because it is creating new array to store new element. That is why it is taking theta n. But here is the catch. If we compute the overall time complexity of all the add operation or insert operation, we can simply calculate it using the sum of all the time complexity divided by number of elements. Okay, so here theta 1 5 times is going to be theta of n plus theta n divided by n plus 1, and if we solve this we get theta of 1. So this means even if we add the element in the last or in the middle or in the first, the average and amortized time complexity of these operations is going to be theta of 1. Okay, so to understand the concept of average and amortized time complexity, let's see this example. So let's say every month you are earning $100 a month. Okay, but in the year end you earn $500 in bonus. So how are you going to calculate the average income of yours? It's simple. You are earning $100 per month, so you are going to multiply 100 by 12 plus $500 as a bonus, and you divide it by 12 plus 1. So this is how you get average income per month, right? So this is the same concept we are using here, that even if you are adding element in the end or in the middle or in the front, the average or amortized time complexity of insert operation is always going to be theta of 1. Okay, so I hope this is clear to you. So now let's move on to the next section of this video where we see the differences and similarities between array and ArrayList. Okay, so the first difference between array and ArrayList is array is fixed size, whereas the ArrayList is growable size, right? In case of array, we cannot increase or decrease the size of array, but ArrayList internally grow and shrink its size based on the number of elements. Okay, now the second similarity between array and ArrayList is we can add duplicate elements in array. And similarly, we can also add duplicate elements in ArrayList also. Now the third similarity is we can have elements stored in contiguous memory location in array. Okay. Similarly, ArrayList also internally uses array. That is why in ArrayList also elements are stored in contiguous memory location. Now the next thing is insertion order is preserved in array. And similarly, insertion order is also preserved in ArrayList. So the order in which you add elements, in the same order you can also remove the element, or you can traverse the element in the same order. Now the next one is array can only store homogeneous elements, right? So if we have array of type integer, we can only store integers. If we have array of type boolean, we can only store booleans. If we have array of type float, we can only add float values. Okay, but in case of ArrayList can hold heterogeneous elements. This means you can add integers, strings, character and objects all together in ArrayList. Now the second thing is null is not allowed in array. This means in normal arrays we cannot add a null to any position, but in case of ArrayList null is allowed. And mind you, why null is allowed in ArrayList? Because ArrayList only works on non-primitive types. So does this mean that we cannot store primitive types in array? Absolutely no. We can store primitive types in array. That is why the wrapper class of all the primitive types is available in Java. For example, integer is a primitive type and the wrapper class over this integer is available as integer. Okay, capital I integer. This class is same as this class, but this class is just wrapper our integer primitive type. Similarly, in case of boolean primitive type, we have wrapper class for boolean that is capital B OOLEN. So this class represents the primitive type boolean. But these two classes are reference type or non-primitive type, but these two data type is primitive type. So that is why null is allowed in ArrayList. So let's say if we do not have an object, we can store null in that place. So I hope guys now you understood what is the difference and similarities between arrays and ArrayList. Now let's move on to the next section where we discuss what are the advantages we get while using ArrayList. So the first advantage we get while ArrayList is random access. And what does it mean by random access? Let's see it. So as we know that in ArrayList all the elements are stored in contiguous memory location. So let's say for example the first element is stored at location 100, the address of memory location is 100 and the size of this element is 4 bytes. Okay? And the second element is stored at location 104, similarly third at location 108 and so on and so forth. Now let's say I want to get the element at index 3. Then how are we going to get element at index 3? It's simple. What do we have to do? We have to do 100, that is the base address of the array, plus 3 is the index into 4 is the size of element. So if we calculate this, we get the address of third index, that is equal to 112. And what is stored at that location? Number 4. So this is how we can get element at any index in constant time complexity. And why are we able to do this? Because all the elements are arranged in contiguous memory location. So that is why we can randomly access any element in big of one constant time. So the next advantage we get while using ArrayList is it is cache friendly. Okay, let's understand what does it mean by cache friendly. So let's say we have this array. So this array is stored in contiguous memory location inside the RAM. Okay. Now what happens when you try to access element 2 of this array? Your CPU is going to store all the elements nearby 2 into the cache memory. And why is like that? Because cache memory is the part of CPU. It resides in the CPU and it is the fastest memory among all the memory. So that in future, if you try to access element 4 and 5, your CPU do not have to go to RAM and pick the elements. Rather, it can simply get the elements from the cache. So long story short, cache is used in CPU to improve the performance of the operations or applications. So in case of arrays, as it is stored in contiguous memory location, your CPU is going to store all the nearby elements in the cache so that if we use in future, it can easily get the elements from the cache and it do not have to make a round trip to RAM to search and get the elements. So this is why we really get a very good performance when we use arrays or ArrayList. Now the second important advantage while using ArrayList is dynamic size nature. And we already know about this feature that ArrayList can simply grow and shrink in size. So we do not have to worry about whether the array gets full or not. So these are the three major advantages of ArrayList. Now you might be thinking about this question that when to use ArrayList. So there are two general rules where you can use ArrayList. First one is, let's say you do not know the size of array in advance. In those cases you can use ArrayList. To understand this point better, let's take an example. Let's say you are developing a software for event, okay? And you are expecting that 500 people are going to register in this event. And by assuming these, you just created an array, normal array of size 500. And what happens? Unfortunately, only 200 people get registered on this event. So what is happening over here? You have created array of size 500, but the actual space you are using is only 200. So in this case, you are simply wasting space for 300 more elements, right? So wasting space simply means you are wasting memory, okay? And memory is crucial. So in those type of case, if you had used ArrayList, then what happens? ArrayList automatically grows and shrink in size. So in case of ArrayList, it never going to grow beyond 200, right? So this is why we prefer ArrayList in those type of use cases. Now the second advantage is faster access. So whenever we need faster access over something, for example, you want to randomly access or access any element in constant amount of time. In those cases, we prefer using ArrayList. And as you can see here, that we can randomly access any element in constant amount of time. That is why whenever you need faster access, prefer using ArrayList. So I hope guys, so far everything is clear to you. Now in upcoming videos, we are going to see all the operations we can perform over ArrayList and what are the time complexity of all the operations. So on this note, let's end this video. And guys, if you have learned something valuable from this video, then hit the like button to make YouTube algorithm happy and subscribe to this channel, and don't forget to click the bell icon so my friend you never miss any upcoming videos. So this is all from my side. Thanks for watching. See you in the next one.